Okay, so we are nearing the end of this unit, which was all about solving equations. And I have to say, you guys, you have been impressing me every day with your solving abilities. I am totally impressed, and so good job. We have the next couple of days, we're going to be talking about inequalities. We've been solving equations with an equal sign, but now we're looking at inequalities, which means not exactly equal to, but it's a little bit more open. So we want to be able to solve inequalities. An inequality uses a different symbol. It's sort of a little bit extra. So the less than symbol could look like this. So it's the little Pac-Man guys, which I know you guys have seen before. You guys have seen those, I guess since 5th grade, maybe 4th grade, somewhere around there. I think you've seen them for quite a while. Anyway, so we have the less than symbol. What we're actually going to be doing is we're also going to be graphing solutions on number lines. And so when we graph them on a number line, if we have the less than or greater than symbol, so these are our two symbols, less than or greater than. And if we have those symbols, when we graph on a number line, we use an open circle to indicate that that is not including the actual number. I'll talk more about that in just a second. We also have less than or equal to. So here's less than, and we put the extra bar under it. It means that it can also be equal to. And do you see how it's kind of like an equal sign right there? All right, so it is less than and it is equal to as well. So it's a combo. It's a 2-for-1. All right, and because it's equal to, then we use a nice little solid dot when we're graphing. So we want to, and that means that the answer is also included. The actual number is included. Greater than or equal to. So we've got the greater than symbol, but it's got the little extra equal to part. So we have this equal to sign as well. And again, we're going to use a nice solid dot when we're graphing. So what we want to do is be able to graph and understand what we're talking about when we use inequalities. It means that there's actually a lot of answers, many possible solutions instead of just one solution, which is what we've been working with for a long time. So we could have many solutions. And the best way to talk about it is when you see a variable, I would like you to replace the variable. Don't just say X. We're going to say any number. Instead of X, we're going to use the phrase any number. And then what symbol is this? Greater than. Now, I don't actually like to use the words greater than or less than. I think they're less specific. So when I do that, I start with my any number, and then I see that I have the big side right next to my variable, the big side of the Pac-Man, okay? And so I say, hey, I want any number bigger than -8. What's a number bigger than -8? -7 is bigger, -6 is bigger, -5 is bigger. Anything to the right is bigger than -8. You guys on your computers, you should not be on your computers. So close it up. So what we're going to do to graph each inequality is we're going to go ahead and make a number line. And I'm very interested in this number -8. So I'm going to put -8 right in the middle. And then to the right would be -7, -6, -5. What's to the left of -8? -9, -10, -11. Now, this says I want any number bigger than -8. So because it's just bigger than, at -8, I'm going to go ahead and use an open circle. And where are the bigger numbers? To the right. So what we do is we draw a little arrow to the right. And so there's a lot of answers here. Any number bigger than -8 is part of the solution, okay? So again here, I have, instead of saying just K, I'm going to say, hey, any number. Now, when I look at this, what side is this little arrow? Is that the big side or the little side? It's the little side. So I'm going to say any number littler than 5. What's the number littler than 5? 4, 3, 2, 1, all those numbers to the left. So once again, we're very interested in number 5. And we're going to fill out our number line. So to the right would be bigger things like 6, 7, and 8. And to the left would be littler things like 4, 3, and 2. And so at 5, I'm going to use, should we use an open circle or a closed circle? Yeah, because we're equal to 5 is actually part of the answer. And we want any number littler than 5. And where are all the littler numbers? To the left. So we make our arrow to the left. So anything in this arrow region, we're sort of including in our potential answers. So we have lots and lots. 2 is littler than 5. 0 is littler than 5. Okay, and that's what that means. These are all the possible answers. Let's go down to number 5. These are backwards, aren't they? Do they look backwards to you? Yeah. So what I want you to be able to do, happy birthday, by the way, thank you. What I want you to be able to do is when we're reading these, we always start where the variable is. So I'm always going to say, hey, I'm not talking about P, I'm talking about any number. So I'm starting over here, any number, and what side is next to my variable here? Is this the big side of the arrow or the little side of the arrow? The little side. So I want any number littler than 7. All right, so here we have 7, 8, 9, and 10. And then we have littler numbers like 6 and 5 and 4. And so when I read this, I'm saying to myself, hey, I want any number littler than 7. So should I use an open circle or a closed circle at 7? Open circle. And then where are all the littler numbers? To the left, littler to the left. And this is why I like to say it that way. Instead of greater than or less than, I said bigger or littler. Okay? And littler numbers are to the left, which I think is helpful. All right? So all these numbers, 6 and 5 and 4, but also like, hey, 6.9 is littler than 7. So we're including all of the numbers in between there, okay? On number 6, again, I'm saying any number, which side am I looking at here? Do I have the little side of the alligator or the big side? The big side. So any number bigger than -2 is how I would read that. So I have -2, what's to the right of -2? -1, 0, and 1. And to the left would be -3, -4, and -5. All right, so I want any number bigger than -2. Should I use an open dot or a closed dot? Yeah, closed dot because of the equal sign. And it says any number bigger. Where are the bigger numbers? To the right. Now, I also want to point out to you that if you don't like the order of this, we can switch it around, okay, if it reads funny to you. I can switch it around, but I want to keep the orientation the same. So if I wanted to rewrite this, if I want to put the variable on the left, the letter on the left, my little side of my arrow is next to the P. So when I turn it around, I still want that little side next to the P. All right, so if you turn it around, the arrow turns too. Okay, and so on this one here, if I have the N on the left, I have the big side next to the variable, so I want my big side still next to the arrow with an equal sign and -2. So you can turn them around, you just need to make sure your orientation of your arrow stays the same. Does that make sense to you? All right, big side next to letter or little side next to letter. Okay. So we also want to be able to translate these inequalities. And so we might want to say, hey, what can we do for a number? What can I say for a number? X. Yeah, we can say X. A number is less than 4. So I'm going to put my little side next to the variable, and this would say any number less than 4, and I could graph that. So 4, 5, 6, and 7, 3, 2, and 1. Should I use an open circle or a closed circle? Open circle at 4. And we want any number less than 4. Should that be to the right or should we shade to the left? Yeah, we're going to shade to the left. All right, so there we go. Any number less than 4. All right. A number is greater than or equal to negative 18. So what can we use for a number? We could use a Y. We can use any letter we want, sure. A number greater than or equal to. So that means that we got the big side next to our variable, and it's got the little equal to with it. Greater than or equal to negative 18. So I'm going to make my number line negative 18, negative 17, negative 16, negative 15, and to the left, negative 19, negative 20. No, your number line has to be always thinking about, like, if you started from 0, right? We'd have 1, 2, 3. Here in the negative land, the numbers get bigger. You guys, can you stop, please? All right. So when we're looking here, if you imagine going down to negative 18, you'd have first, you'd see negative 15, and then 16, and then 17, and then 18, and the numbers look like they're increasing to the left. Because it's awesome. Because they've built in a ton of review in middle school math, that's why. All right, let's see here. At 18, is it open dot or closed dot? Closed dot at 18. And this is, we want any number bigger than 18. Where are the bigger numbers? To the right. So we're going to draw our shading to the right there. Okay. Let's talk about number 9. A number is at least 2. I find these things very hard. What does it mean to be at least negative 2? It's got to be bigger than. Very good. So when I read something like this, I have to translate it to myself. I have to say, hey, if I'm a number that is at least negative 2, that means at my lowest, I'm negative 2, but I want to be bigger than that. At the very least, I'm negative 2, but I need to be bigger than that. So I want any number, my x, to be greater than or equal to negative 2. So when it says at least, that really means at the littlest. At the lowest, it's negative 2. So at the very bottom, it's negative 2, but I want to be bigger than that, okay? So I have negative 2. To the right, we have negative 1, 0, and 1. And then we get smaller, which is weird. All right, so at negative 2, do we use the open or closed dot? Closed dot at negative 2, and we want our number to be bigger than that negative 2. At the very lowest, it's negative 2. All right. Do you have a question for me so far? No? Okay, great. Real fast here, we want to state whether the number is a solution. So we want to know if we take the solution of 4 and plug it in, is it true or is it false, is what we're asking. So we want to ask, does 4 work? If I plug in a 4, is 4 greater than or equal to -6? Is 4 bigger than -6? Yes, this is true. So then yes, it's a solution. So this is all we're doing. Is it true or is it false? So number 13, I'm going to take 11 and replace the n. Is 11 littler than 8? No, that's a false statement. So 11 is not a solution. So it's a true-false game. True means yes, a solution. False means not a solution. All right? Questions on that? Easy? True, false? Okay, turn the page. All right. So it turns out, here's what our goal really was. Solving inequalities. This is what we really care about today. To solve inequalities, we follow the exact same steps as we did for solving equations. However, if you multiply or divide by a negative number, you must flip the inequality symbol. This is absolutely the most important thing. That negative is going to cause your inequality to flip because it's saying the opposite of. And so we have to flip the inequality symbol. So anytime you multiply or divide, we're going to flip that inequality symbol. So let's go ahead and look at number 19. Number 19, the inequality symbol acts just like our equal sign, so there's a wall through that inequality symbol. What would we want to get rid of first here? The 6, yep, so we're going to add 6 on both sides. And so I have a number divided by 5 is less than or equal to 12. Now, this is a number divided by 5. How do we undo divide by 5? Times by 5 on both sides. Times by 5 and divide by 5 cancel out, and I get A is, yeah, do I have to flip the inequality symbol here? Yeah. Did I multiply by a negative number? No. Okay. So I don't have to change anything. That one is just fine. So this is our solution. We want any number littler than 60. So on my number line, I'm going to graph 60. What should I write to the right side of 60? 61, 62, that's good. And then to the left side? 59, 58. Okay, that's good. Now, at 60, should we use an open or closed circle? Closed circle. And this says, remember, any numbers littler than 60. So littler numbers would be to the left of 60. So 60 is an answer and everything small. Yes, ma'am. The number line? So I'm okay if you write the 60. Yeah. All right, let's look at number 20. Number 20. Again, we want to solve for y. What should we do to solve for y here? Minus 22. Good. All right, so negative 2y is littler than... What is 18 minus 22? Negative 4. Very good. And then I need to, how do I get y by itself? Divide by negative 2. I'm going to divide both sides by negative 2, but because we are dividing by the negative value, we have to flip our inequality symbol around. So we get y is, now our arrow is pointing the other way, and negative 4 divided by negative 2 is positive 2. So you do have to flip that inequality because we divided by a negative number. So I have a 2, 3, 4, 1, 0 on the other side. Do we have an open or closed dot at 2? Open circle, and this says we want any number bigger than 2, and bigger is going to be to the right. Any number bigger than 2. All right, how you doing? You doing okay? All right, let's look at number 22. Number 22, what should we do first? Minus the 4, good. So I get W divided by -7 is greater than, what's 5 minus 4? 1. Now it says W is divided by -7. How should we get rid of divide by -7? Times by -7 on both sides. What do I need to remember to do? Flip my symbol. And why do I flip my symbol? Yeah, we're multiplying by a negative number, so we need to flip our symbol because it's really saying the opposite of what we have here. So we have W now is littler than -7. So I have a -7, a -6 and a -5 to the right, -8 and a -9 to the left. Open or close dot at -7. Open dot, and we want numbers littler than -7. Where are the littler numbers? To the left. Littler numbers go to the left. Beautiful. Let's just do this last one, number 24. And we'll call it good. Number 24. Number 24, what should we do first? Add 16 to both sides. Beautiful. So we have 3/8 x is less than, who wins here? Negatives or positives? Negatives win by how many? 9. Very good. Now, how do I get rid of this fraction in front of my variable here? Multiply by the reciprocal. Very good. That is the easiest way. Multiply by the reciprocal. So we're going to multiply by 8/3 on both sides. The times by 8 and divide by 8, times by 3 and divide by 3 cancel out real nice and neat for us, so the x is alone. Do I need to flip my symbol here? No, I do not, because 8/3 is positive, so I don't have to flip it, so that stays. This becomes right straight across here, -72 divided by 3, which I think is -24. Yeah, okay. All right, so I have a -24, -23, -22 is to the right, -25, -26 is to the left. Open or close dot at -24? Open, because it's just doesn't have the equal to on it. And we want numbers littler than -24. Where are the littler numbers? To the left. All right. Do you have any questions for me? Okay.